Hello, good afternoon, all. Good afternoon, all.
Yeah, good afternoon, sir.
Alright, I welcome you all.
I can hear you, sir.
So, have you all downloaded our last video, our last lecture? Have you downloaded it? The video?
No, I couldn't download it. It was saying that file wasn't found or
Okay,
something.
but you have to send a request to me. You know how you usually open it? You try to open it, enter the video, and then it will give you an option to request the video, and then I'll approve it. Try it one more time after the lecture. If you can't access it, then you let me know. Booker, so I can send it to you, eh? Or I can resend it again. Hello, Rukaya.
The line is breaking, sir, but I can hear you now.
Yeah, you can't hear me?
You're breaking off.
Okay, okay. What I said is, you try and download it again. What you're supposed to do is to try to enter the video. Then the video will give you an option to request for the video. Can you hear me now?
Yes, sir.
The video, you try to enter the video, and then the video will give you request for the video. So when you request it, then I'll approve it. But if you can't get it, if you can't access it after doing so, please let me know so I can resend it again.
Okay.
It seems like you're all having a bad network or something. Rukaya, Abdul Samad, they're all quiet. I don't know why.
No,
Yes,
sir.
sir. Hello.
Sir, I was the one that was saying something about the not being able to see
Okay,
the
yeah,
file.
yeah. All right then. Good. Yes, I've heard you. I've heard you. So try and download it again, Muhammad. Are you with me?
Okay.
After today's lecture, you try and download it again.
Okay.
All right. So today's lecture is on measurement. After today's lecture, we're not going to. By next week, hopefully, we're going to start our experiment. So we're going to start our experiment hopefully by next week. So today is going to be our last lecture on introduction to electricity and magnetism. So today's lecture is measurement. Just as physics 107 or mechanics, we do have so many equipment that we're supposed to take, that we're going to use in taking measurement in electricity and magnetism. Same way we have equipment in measuring different mechanical equipment such as micrometer, screw gauge, vernier caliper, meter rule, stopwatch, and so on. So we also have other equipment that we use in taking measurement in electricity and magnetism, other forms of equipment for a specific problem also. So today you're going to learn how to use some of these equipment. We're going to start with the meters, and then we'll move to the board itself, the board that we're going to use in our circuit configuration.
Okay, sir.
Okay. Okay, these are some of the equipment. We have multimeters, and these three multimeters are of different formats. So if you look at the first one with yellow cover, the first one with yellow cover, you see that we have, okay, let me see if I can zoom it. I don't think so. The image is a bit, okay. If you look at the first multimeter, we call it digital but manual. It's a digital multimeter but manual. The reason why we call it manual is because after choosing the, the, the device that we're going to take our measurement from, then we'll have to also set our range. After choosing the device, we also have to set our range of value. So if you look at this one, we have off here. This is off. When you are not working with it, you make sure that you set it to off because these are, before we start our experiment, I'm going to give you all these precautions. Whenever you're using any of our electronic devices or any electronic devices, you have to make sure that you only start it when you are about to use it. This is to save your battery and to make sure that you have to maintain accuracy. So when it's not in use, you make sure you do start it. Then if you look at next to 100 by the left, we have about 20 mega ohm. This 20 mega ohm, 20 mega, who knows what mega stands for? All these metrics, you have
Megahertz.
Mega. How many thousand is mega?
10,000. Huh?
10,000?
No. The kilo is 1,000.
Is it not million?
Yeah, million. Kilo is 1,000.
Good. Million is mega. So we have 250 watt mega ohm, which is equivalent to 250 million ohm, right? So from the unit ohm, you should know that this is what? A meter for resistor, for measuring the resistance of a resistor. So this one has to do with range. That's why we call it digital but what? Analog. Sorry, digital but manual. So after this 250, we have 200, we have 20 kilo ohm. I believe you all know what kilo stand for. 1,000, right?
Yes,
So
sir.
we have 20,000 ohm. After that, we have 2 kilo ohm, which is equivalent to just 2,000 ohm. And then we have 200 ohm. So after this is where meter for resistance stops. From here, it goes to here. All these are what? Meter for measuring the resistance of a resistor. So now, if you are given a resistor, then you have to work with value, with range before you'll be able to get the precise value of that resistor, or before you'll be able to know the exact resistance of that particular resistor. So now, if I give you a resistor of 20 ohm and I ask you to use that type of multimeter, this type of multimeter, the one with yellow pin or cover, I ask you to use it to measure the resistance. What you have to do is to look at the range that your 20 or the value of the resistance you are measuring fall within. For example, if I ask you to measure 20 ohm, then you will have to look. The last value here is 200 ohm. And that 200, it means it can accommodate value within 200 down to 0. So any resistor that falls within 200 down to 0 can be measured by setting your calibrator or pointer at exactly this 200 ohm. I want you to be looking at my cursor. When my pointer, so that's where my pointer is at 200 exactly. So that's where you're supposed to set that your pointer. Sorry, not the pointer on the breadboard, on the multimeter, but the pointer on the cursor of my computer. This is the cursor is exactly on 200. So that's where you're going to move this pointer. You move it to this 200, and you will be able to measure the resistance of any resistor within 200 down to 0. And remember, resistor is a very easy equipment to measure. But in a situation whereby you don't know the resistance of a resistor and a value is not written on the resistor, then you have to learn how to use your color coding method, because resistors are of different types. We have the color coded ones. We also have the yes, I think the color coded are, yes, we have the ceramic. Do you know what the ceramic is? Have you ever seen the ceramic resistor?
No, sir.
Yeah?
No, sir.
Okay, don't worry, you're going to see all of them during our experiment. So we have we have resistors of different type. We have the fixed ones, we have the variable ones. The fixed ones are those with a limited value. Let's say I have 2 ohm resistor. You should know that it can only work with for 2 ohm to some certain fraction above or below 2. So the same thing with then we have variable, which you can vary, and we have the voltage divider resistor. So you're going to see them all. You're going to see them in the lab. Okay, so if you know the range of the resistor, because some of our ceramic resistors here in the lab have range of values, you'll be given a resistor that has a value written on it within 7 to 8 ohm or within 7 to 10 ohm. So if you have those kind of resistors, then you can use your yellow multimeter, this digital board manual resistor, multimeter, to know the precise value or to exact resistance of your resistor, but by setting it to the range. Yes. So if I say I give you a resistor with a value written on it 10 to 6, 10 down to 6 ohm, then you have to put it, fix it at 200 ohm, because this is the minimum. This 200 will give you the exact value within that 10 and 6 ohm. And also, if let's say, for example, I give you a resistor of 30,000 ohm, which is equivalent to 3 kilo ohm, then you have to look at the value. This is, we have 2 kilo ohm here, and 3 kilo ohm is above 2 kilo ohm. But if you look at the value above, is 20 kilo ohm. So if you fix it on 2 kilo ohm, it means it can only take a value within 2000 ohm down to 200 ohm, or a value before or close to 200 ohm, which we can say 201 ohm up to 2000 ohm. So if you are given a resistor with a range of value within 3 or 30,000 or 3,000, let's say 3,000. 3,000 is above 2,000, so you have to fix it on 20 kilo ohm. And also, if you are given a value with range above 20 kilo ohm, then you have to fix it on 200 kilo ohm. So this is how to take measurement. You have already seen your pointer is already on off. So it's only when you're about to use it that you move it to the particular meter that you are going to take measurement from. Okay, the next thing is current. If you look at from this, we have a diode meter. This is a diode meter next to resistor. We have a white color here, a very brief white color here. This white color is only when you're going to measure a diode or transistor to see if it is working, or if you want to know whether your diode is PN or NPN, or transistor is NPN or PNP, or you wanted to test an LED to see if light emitting diode is working or not working. Then after this diode meter, we have current meter. It started from 10 ampere, then 200 milliampere, then we have 20 milliampere, and then we have 2 milliampere, and then we have 200 microampere, we have 20 microampere, and then yes, this is where the value for current stops. All right. Are you with me?
Yes, sir.
Okay.
Yes, sir.
So, a minute. I need a minute, please.
Okay, sir.
Hello?
Hello, sir.
All right, I'm back. Then next to current meter, we also have range of values. We have millimeter. This 10 ampere, it means when you have anything from 10 ampere down to 0 0.1, 0 point, anything down to 0, you will fix it on 10. If you want to take a measurement, this 200 milliampere is something as 200 divided by 1000, which is equivalent to 0.2 ampere. So this is when you have a value greater than, when you have a value within 0.2 down to 0. And we have 20 milli, which is also another small value. This is also 2 milli, which is somewhere around 0.00 something. And the reason why we are having a very small value for current is because current will hardly go above 10. The maximum current that you can use to measure with this is just 10 ampere, and you don't need current above that. You can hardly have a current above that. Even when you have electricity flowing through, even the domestic electricity we have here in Nigeria that goes through our houses is within 240 volt. While the current equivalent for that particular, for the 240 is somewhere around 10 ampere. So current is always within that value. Even if you look at if you check the adapter of your computer, you will see that the current flowing through, the voltage that comes from your AC power source is somewhere around 240, while your regulator will drop it down to either 15 or 10 volt. And then the current equivalent is going to be somewhere around 2.5 ampere. So current maximum is just 10 ampere. And then after this, we have a voltage meter. For voltage, we have two different we have the DC and AC voltage. But this kind of, if you look at this, V with two lines stand for DC voltage, meaning the kind of voltage that you can measure from a battery, DC source, which is a battery, and this one is a kind of voltage that you measure from directly from your electric generator, such as socket. So your voltage also is divided into two. The white color here is for AC voltage, and AC voltage is always big. That's why we're having a big values here. And then we have, as I've said earlier, the kind of voltage that goes through our circuit or that comes from our electric generator is somewhere around 200 and something. And as you can see, the limit or the voltage range we have here is started from 200 and to 600, because these are the value, the minimum and the maximum value that you can achieve within from our electric generator and almost all the AC sources, solar panel or anything, all the sources, AC sources that you can think of. So if you go above, you see this is a DC voltage, and these are the kind of voltage that we can have from our battery, from our TV remote, from many DC sources. And most of the voltage that comes out of DC sources are smaller, so the values or the ranges are also small. So we can use this multimeter to take all this sort of measurement. So the second multimeter, we call it digital and also automatic. So the reason why we call it digital and also automatic is because all we have is AC voltage V, DC voltage with two lines, and then maybe a capacitance meter in farad, and maybe the diode meter, and then yes, capacitor here, and then current. So you don't have to bother about taking a range. All you have to do is to just fix it on that particular meter that you wanted to take your measurement from, and then the multimeter will do the entire work. You don't have to care about range. All you have to do, if you want to measure voltage, if it is AC, if it is from our electric circuit, all you have to do is to fix it on AC, and it's going to tell you the value no matter how big or small it is. And also, if you want to take measurement from a DC source, all you have to do is to fix it on what? A voltage of a DC source. Then all you have to do is to fix it on DC voltage, and it will give you the precise value. So this is automatic and digital. Then the next one here is also known as what? Digital, but what? Manual, because you have to fix it because it has ranges. But the difference between this one and the first one, I think they don't have difference. They are the same. They have no difference. This one and the first and the last one are the same also. They don't have any difference. So we also have a completely analog multimeter, which I'm sure we have so many of them in our lab, but you're not going to use it because it's too complicated for you, and you don't really need to use it. The world is advancing, and many things are digital now, so you don't need to learn the analog, except if you want to. At your leisure time, you can come over and I'll put you through. So this is all about multimeters, and you're going to be using many of this. We have different types in our lab. We have more than 100 of this in our lab. Then the next device that you're going to be working with is, what do we call this? Do you know the name of this? Who knows what we call
I've seen it before, but I don't know the name, sir.
The name is Breadboard.
Okay. Yes, I know it's like a circuit board that.
Yeah. It's a circuit board. Yeah, it's a circuit board. Okay. Circuit board also are of different types. We have the we have the breadboard and we have the Veroboard. The breadboard and the Veroboard. Okay, let me share my screen to show you how Breadboard looks like. Okay, this is a Breadboard. This is a Breadboard. A Breadboard is a kind of circuit board that you find inside your either phone, mobile phone, or inside your computer, inside your television, inside your electronic devices. This is a kind of, but it's the function of this is the same with that of breadboard. But why do we use this one? We use this one to permanent our circuit, while breadboard is used to what for temporary work. We use breadboard to check whether something would work, whether something that we're practicing or we're experimenting will work. For example, I ask you to develop a circuit that can control, that can use to control, that we can use to carry out some simulation and control, maybe to control a robot or something. So after you figured out the circuit block diagram and the circuit diagram, then you have to make your installation, or you have to make, yes, installation. You have to install your electronic component to what? To the circuit diagram format on your breadboard. So after you set your circuit, you're done with your configuration, then you have to test it to see if it works. So after confirmation, or after you confirm that yes, your circuit will work, or your circuit is working perfectly, or your circuit is faulty or something like that, then you have to what? Amend it using that same breadboard. And then when you are sure that your circuit is perfectly working, that's when you use Breadboard. So if you look at this Breadboard carefully, you see that there are some soldering. There are some soldering attached to it. All these soldering are to what? To seal your components. Remember, you're going to have so many components for you to build up a certain devices. So for this one, we have IC. If you look at it, the black on the circuit here. Okay, let me use my cursor to indicate what I'm trying to explain. I want you to look at my cursor. This is a component, and this component, we call it IC. Can you view what I'm trying to, can you see my cursor?
Yes, sir.
Yes, sir.
So we call it, this is IC, integrated circuit. It can be used for amplification and so many things. We have so many diodes and transistors fabricated on this single devices or component. So many components have been fabricated to come up with one component, which is known as IC integrated circuit. Apart from this, we have another component, this, we call it capacitor. This capacitor here is used for energy storage. For example, when a very good example of this capacitor is your computer uninterrupted power supply, UPS. When power goes off, when power goes off and you are using a desktop computer, you find out that it will take some few seconds or minutes before it goes off, right? So this is because it has so many capacitors in it that are what? That will store energy, and then the energy will be used to what? Retain the power for a certain period of time, a very short period. So this capacitor also, they are used for that. They are also used for what? Power. They are also used not only to store charges, but also as a protection, because sometimes a very huge power will come through this line where we're having a capacitor. Yes, the line we're having a capacitor. I think we have about 2, 3, 1, 2. We have about 3 capacitors in this same circuit. So maybe a very high power voltage is coming through this line. So this capacitor can act as a regulator, will absorb some of the energy and then will pass very few, or will pass the required voltage to the remaining resistors, so that the remaining component will be safe. And then After that, we have so many resistors and very few. Yes, we have, this is what resistor 1. We have another resistor here. We have another one. We have, yes. So some of the components are microchips. You may not be able to see them clearly from this image. So this is Breadboard, and we use Breadboard for what? Permanenting our circuit configuration. This is when you are sure that yes, your circuit will work, then you will permanent it by using a solder iron. Then after this, we have, I've talked about the breadboard, which is what? The temporary circuit board. The temporary circuit board. So this is the temporary circuit board, the breadboard. It's meant for experiment purposes. This is for experimental purposes. You only use it to experiment. So now, the next thing is to learn how to use this breadboard, because most of the circuits that we're going to be build we're going to use this breadboard to build it until we're sure or certain that yes, our circuit will work before we transfer it to breadboard. So now, how do we work with this? We have so many holes here, but some of the holes are in parallel while some are in series. So I'm going to sketch my own breadboard, and then we'll discuss about it and apply the same thing to our main breadboard.
Breadboard, you see numbers 1, 2, 3, 4, 5, 6, 7, right? Up to 30. So let's say I want to connect my capacitor from position 2 to position 5 of the upper part of the breadboard. I want to connect it from 2 to 5. 2 to 5. I believe I don't have to zoom it, right? You can do it. Can you all see the numbers? 1, 2, 3, 4, 5 to 30.
Yes, we can.
All right, so let's say I have my capacitor. So I want to connect positive from 2 to 5. So you can choose any of the holes. I can say yes from the second to the second 5. Remember, if this is my positive, then this should be the negative. So So if I want to make another connection,
Hello?
We can hear you, sir.
You can hear me? Okay. Are you following the breadboard?
Yes, sir.
All right, good. So I want you to listen and understand it. If you have any question, then we can go about it.
finish with this resistor. I have already made connection 1. So I want to connect the second capacitor. Sorry. I made connection 1 for the third capacitor. Remember, capacitor has a symbol of just line. So I have one capacitor. The second one that I'm going to connect in series with this one. Remember, series configuration is what? In your vertical axis. This is series, vertical. Horizontal is parallel. So I can now say the second one has to be in what? Remember, in series should be vertical, so it should be under. The positive should start from the negative. Directly under what? 5. And then it can go to another 8 or something. And that 8 will be your negative. So from there, these two capacitors are now connected in what? In series. Remember, capacitors in series will be reciprocal because they have polarity. Unlike resistors. Resistors don't have any polarity. When we have resistors in series, all we need to do is what? To sum up the value. Add the resistor 1 with 2, and then we'll have the total resistance. But for capacitors, it's completely different. Then it means you have to take what? The reciprocal of resistor capacitor 1, you sum it with the reciprocal of capacitor or capacitance of capacitor 2. And then you take the summation and then you take the reciprocal of the total capacitance with the reciprocal of the fraction, and then you come up with the total capacitance. So now we have these two capacitors, and now they are connected in series. The next connection is to lead to your battery. Now we are assuming that we have our battery here connected negative on the and positive on the red. So now for us to complete our cycle, we'll have to take one connection from the positive and put it in next to the positive. And then we take another conductor, we plug it from the hole next to the negative and take it back to the negative. So we have completed our cycle. So this configuration is something as having something like this. This capacitor connected to a battery. This is the configuration we just made. And we have our capacitor 1 and capacitor 2. So this is our configuration. But if you want to make parallel configuration, which is something as this, then we will have to this is parallel. So for us to make parallel now, if one capacitor is starting from 7, I will say 7. I have one capacitor from 7 to 20, positive, negative. The second one must start from that same line from positive from 7, but under. We can take our 7 now from here to here. Capacitor, positive, negative. And then we can make connection between this back to the negative and this to the positive. So this is how to make parallel configuration. Have you seen the series and parallel? This is series and this is parallel. Series, parallel. So now we're going back to our
So I have a question.
okay, yes.
For the series, don't they have to be like on the same line? Because in the series now, they are on different lines.
Okay, no, they can't be on the same line.
Muhammad,
Yes, sir.
did you ask a question?
No, I didn't. I think it was.
Okay, okay, you are okay, ba?
Yes.
All right. If you
I
have
don't know if someone else.
no problem, let it finish first. Let's finish
But
before.
if you make it in the same line, the same thing as saying you are trying to make you short side two to the two, and therefore they are not going to be charged. They can only be destroyed. So if you put them on the same line, it means they are having the same current. Sorry, the same line. It means they have no bridge. Sorry, they have bridge between them. They are not connected. Remember, I said the connection is under downward. It's going downward. So the only thing that links capacitor 1 and 2 in series is because the negative of 1 is connected the same line vertically with the positive of the second one, which is 2, right? Are you with me?
Yes.
That's what makes the two in one series, because one is adding to another. But if you look at the parallel configuration, they started in the same position and ended in what? Same position, right? So that shows that the connection is going downward, which is what vertically. There is no connection in what? Horizontally. Now, for example, let's take the lower part of the breadboard. If I choose, let's say I take capacitor from position 3 to position 7, you are saying that if I can connect another one, let's say from 8 to 12, which is another positive to negative. That's the question, right?
Yes, that's my question.
Yeah, so what I'm going to tell you is that there is no connection between them now. Do you understand?
Oh, okay. I
No
understand what you're
connection
saying.
between them now. Yes, because the connection goes downward in a vertical manner. If you want to connect them, you have to make sure that they are attached downward. The next one should be either here, or here, or here, or even here. Do you see it?
Yes.
So that's how to make the connection. And you, for you to take it to the battery, then you also have to be on the same line, either vertically, either upward or downward. For negative also must be from the same back to negative. Do you understand?
Yes, sir.
All right. Okay, so now let's go to our multimeter.
Okay. Do you understand the setup on the breadboard? If you have any question, you can ask. The setup on the breadboard. Any question?
None from me, sir.
Okay. So the remaining members of the class are so quiet. Are you sure you're with us? Abdul Samad, are you with us? Rukaya and
Yes, sir.
Leslie.
Yes, sir.
Leslie Joshua, are you with us?
Yes, sir.
Okay, is it clear?
Yes, sir.
Okay, good. So this is how to work with breadboard. As I've said earlier, we're going to use breadboard to construct so many circuits. And our main experiment are going to start by next week. We're going to start our experiment by next week. And as usual, we take experiment 1 today, this week. We do the analysis on experiment 1 the next week. That's what we're going to do. We take the second one, upper week. The next upper week is going to be the analysis on second experiment. That's how we're going to take our time. So are you with us?
Yes, sir.
So this is the end of today's lecture. It's all about measurement, how to carry out your measurement and how to set up your circuit. So our components, during our experiment, you're going to learn more about our components, depending on what we are trying to do, or what we are proving, or what we are constructing. So you will learn more and why we are using those components during our experiment. Are we okay?
Yes, sir.
Yes, sir.
All right, good. So I'm going to sign, we're going to sign attendance now. I will view it. Abdul Karim. Okay. Abdul Salam Abdul. Sorry, Abdul Salam Abdul Sulaiman. Abdul Samad Mustafa Uthman.
Yes, sir.
Aliyu Bature Babangida. Aliyu Kalambaina. Bemshima David first. Darlington. Ayo Oku. Fauzia Abdullahi Salisu. Polari Jimmy Marcus. Leslie.
Yes, sir.
Modu Isaac Haman. Mahmoud Baba Malam Wali. Majida Muhammad Abdullahi. Muhammad Bukar Kabir
Yes,
Bukar.
sir. Yes, sir.
Musa Yahaya. Rukayya Aliyu Abdullah.
Yes, sir.
Somto Chukwu Gloria. Muhammad Bukar. Has she resumed? Gloria.
Yes, sir. I think there was a problem with her registration. She's trying to verify it.
But we can invite her so that she will not keep missing her classes. I don't know.
Okay, so I'll remind her. I'll remind her.
All right. Invite her, please. You already have the link and everything.
Okay, sir.
Thank you. Ummi Natu Aleru Saidu. Victor Basi. All right. I think that's all for today. So I hope you've heard your name, all of you.
Yes, sir.
All right. Thank you. Have a good night.
All right. Thank you.
Thank you.
Thank you, sir.
Thank you.